Definitely going to use that Wolfram Alpha tool again, but I thought I should talk through the opening of this one more time. If I want to find g prime of -1, and this is my equation, g prime of -1 is going to equal the limit as h goes to 0, 2 times -1 plus h cubed minus 5 times -1 plus a little bit squared plus 1 minus what I would get if I plug -1 into this function itself. So that's 2 times -1 cubed is just -2. -5 times -1 squared is going to end up being -5. And then 1 is 1. All that stuff over h. So this part's me plugging -1 plus h into g. And this part's me plugging -1 into g, but not doing all the math all at once. Now I'm going to tab over to Wolfram Alpha and have it expand this part for me. So if you want to see that, I'll do that right now. I'm going to pause a little bit. Actually, don't have to pause because it's right here. So it's the same function because I'm on the same example. I'm just going to change these 1s to -1s. Of course, if you're using a tool like this, it's important to be careful about how you type stuff in. Press enter. Here it's telling me how it interpreted what I put in there, so I can double check and make sure that's what I wanted it to do. And this is what it's telling me the answer is going to be. So I'm going to pause and recopy this expression into the noteboard and be very aware of exactly what I simplified and what I left behind so that I don't accidentally leave things out. Let me pause this video again really quickly. So all this stuff according to Wolfram Alpha is this expression here. I've got the +1, -2 minus 5 plus 1. And if you're sitting there wondering, hey, why don't I just type that whole thing into Wolfram Alpha? You can. I don't want you to do that. I want you to write this kind of stuff down, and I want you getting used to looking at this kind of stuff and knowing that this is the definition of a derivative, so that when you see this out of context, you recognize it as a derivative. So you can do what you want, man. It's your life. But that's just my strong recommendation coming from years of experience and knowing where kids struggle in the future. All right, so now we're back to basic algebra that you learned as a freshman. This would end up combining totally to make -7 plus 1, -6. And then we have a double negative, so it becomes a +6. So we have a -7, a 1, and a 6. So all these guys knock each other out, leaving us with the limit as h goes to 0 of 2h cubed minus 11h squared plus 16h all over h. I can use that trick, or I can just factor out, like this is the trick I'm talking about. H goes away, you go away, you go away, and then you become squared. So if you don't like that, factor that h out. You have 2h squared minus 11h plus 16 all over h, and these cancel out. H is going to 0. I can plug in 0 now. If I plug in 0, this is 0. If I plug in 0, this is 0, and this is just plain old 16. So I know that the instantaneous rate of change when x equals -1 is going to be 16. So now we'll do one more with the generic function. And if you look at it carefully in the previous example too, you might start to spot the pattern that Sir Isaac Newton proved when he was on quarantine.